Okay, today we're going to talk about a couple of different quadrilaterals. I'm going to go back to this slide again. Over the past few lessons, we've been dealing with quadrilaterals, four-sided polygons. That's the only requirements it takes to be a quadrilateral. We talked about parallelograms. There were 5 requirements to be a parallelogram. And then we looked at specific types of parallelograms and rectangles and a rhombus. And then in the last lesson, we finished off with the square, which has several different uh, properties that share a parallelogram, a rectangle, and a rhombus. So this takes care of this whole family. We've already done that family. So now we're going to splinter off into a couple of other shapes, the kite and the trapezoid today. So we're going to start on slide 30. Not a whole lot on a basic trapezoid as far as properties, but the biggest thing about a trapezoid, now when we talk about parallelograms, opposite sides are parallel. In a trapezoid, there's exactly one pair of parallel sides. So for instance, DC is parallel to AB. Now we call those our bases, okay? The parallel sides are called the bases. So I could turn this upside down and it's still set on a base if that's the way you want to look at it. And these sides on the side, DA and CB, are called legs. Okay, so we have this line right in the middle that connects the midpoint of both legs. This is called the median, or sometimes you see it called the midsegment. We can always find the length of this if we know the length of the bases by adding the bases together. 15 plus 17 is 32. And then taking half of that, or dividing by 2. So half of 32 is 16. So EF is 16. And of course, it should always be a number in between the bases. Okay? So those are the only 2 properties of just a regular trapezoid. Now, we also know if we have interior angles, because of the work that we've done earlier, that all the interior angles of a trapezoid always equals 360 degrees. Okay, and we did that in the table. So that's something to keep in mind on some of these as we go forward also. Okay, now sometimes we have something called an isosceles trapezoid. Now the first 2 properties are the same as a trapezoid. It has exactly one pair of parallel sides. In this case, it's AB and DC again. The median is still half of the first base plus the second base. But this time we have a few more properties. First of all, the legs, AD and BC, are congruent. They're going to be the same length. The diagonals that connect the opposite angles, AC and BD, those are also congruent. And then the base angles. So what that means is this is a base, DC. So angle D and angle C, those 2 angles are congruent. And the same thing up here, angle A and angle B, those are congruent also. So let's look at a couple examples. Now I'm going to go to a separate piece of paper. Okay. It looks the same as yours, but you need to work on yours on a separate piece of paper, and then we'll insert this into your notes. Okay. So the first one says, example 1, find the value of x. So we have these boxes. Now, what do we know about these boxes? What does this tell us? Well, this tells us that these are 90 degrees. Okay. Now, there's a couple ways you can approach this. Okay. I'm going to show you the most straightforward way I know. I know that all of these angles add up to be 360 degrees because there are 4 sides. And in a quadrilateral, the sum of interior angles equals 360 degrees. We've talked about that before. So if I add all of these angles together, it equals 360. So I'm going to combine like terms. 12x plus 13x is 25x. Then the numbers 90 plus 3 plus 2 is 185. So now it's just a two-step equation. I'm going to subtract 185 from both sides. So 25x equals 175. And then divide both sides by 25. X equals 7. So go ahead, pause the video, take a picture of this image, and this is what you want to see in your notes. All right, example 2. ABCD is an isosceles trapezoid. If AC is 3x minus 7 and BD is 20, find the value of x. So I'm going to go back to my notes. These are diagonals, AC and BD. And what do we know about diagonals? They're congruent. So AC equals BD. They're the same. So I'm just plugging this in. AC is 3x minus 7. BD is 20. So I add 7 to both sides. This becomes another two-step equation. 3x equals 27. Divide by 3. X equals 9. So a majority of the battle is setting it up correctly. The rest is just doing the algebra. So go ahead and pause the video again. Take a picture of this and insert it in. So follow the properties of a trapezoid. And as long as you do that, you should be able to set up. Now, some of the problems on today's assignment might say AB is 10, DC is 15. What is the mid segment or median? So then you would go back to your back to how to find the median. You add the first base plus the second base and divide by 2. It might give you a leg. That's 3. What's the other leg? So just look at those properties. They're not quite as difficult as some of these, but some of them are. All right, so let's finish up this unit by talking about kites. Now, kites aren't very common. You don't see them very often. I know the obvious shape that you think of is a kite that you fly, and that's, part of the reason. But this is a kite, okay? And here are the properties. So in a kite, no sides are parallel. So a parallelogram had opposite sides that were parallel. Trapezoids had one set of sides that are parallel. Kites have no sides. Diagonals are perpendicular. Now, in parentheses, out besides perpendicular, to remind you, perpendicular means that where they intersect at, it creates a 90-degree angle. So all of these angles inside where the diagonal crosses over is a 90-degree angle. So you might put 90 degrees in a parentheses to remind you of that. The short diagonal, anytime you have this, you're going to have a shorter diagonal, is bisected. So this cuts it in half, and this is the same length as the other side of the shortest diagonal. Now, the next one says two sets of consecutive sides. So I'm talking about this set of sides and this set of sides are congruent. So IK is congruent to EK. IT is congruent to ET. Okay, those are always going to be the same length. One pair of opposite angles are congruent. So for instance, angle I would be congruent to angle E. They're usually connected by the shortest diagonal. And then the last one, diagonals bisect that one pair of opposite angles. So it cuts this entire angle in half to where KIX is the same as XIT. Okay. So now we're going to look at the example. Now this first example kind of takes us back. I'm going to label some things. If I were you, I would go ahead and draw this back out so you can write on it. That's the best thing I can always do to make sure I know what I'm putting in here is correct. Okay. So this says if KE is 13, EX is 5, what is KX? So what I'm looking at here, this is a right triangle. And I can always find the missing side. Let me call this A. Let's scoot this up just a bit. By using something that we talked about earlier last semester, earlier in the year, called the Pythagorean theorem. So remember this, the squared of the legs added together, a squared plus b squared, equals the hypotenuse squared. And remember what we said, the legs are the sides that touch the square. So we don't know A, we know B, it's 5 squared. Now it doesn't matter which one you label. And this square points, I always like to make an arrow, it points to the hypotenuse. So the hypotenuse is 13. So I'm just going to, squared means 5 times 5, and 13 times 13. So we treat this just like we would an equation. So I'm going to subtract 25 from both sides. Okay. So 169 minus 25, a squared equals 144. I'm sorry, let me move this up a little bit. So then I'm going to take the square root. That's how I get rid of that square. So you can put this in a calculator, but most of you know, what do I square together to get 144? Is 12. So the length of this side is 12. All right, so the next one. What is IE? So I'm going to highlight this one. What is this entire length right here? Well, remember, the shortest diagonal is bisected. So if this side is 5, the other side has to be 5. So what's the entire length? Well, 5 plus 5 is 10. The next one, KEX. Sorry, KEX. My left hand gets in the way sometimes. Is 35 degrees. What is KIX? What is this right here? Well, if these opposite sides are the same, this 35 degrees, then this also has to be. So see how everything is balanced on both sides of a kite? What is KIT? Well, remember, these angles are bisected. So if this up here is 35, then this down here has to also be 35. So the total, KIT, is both of these angles put together, 70. And then the last one, what is IKX? What is this right here? Where's that angle right there? Well, we know this is 35 degrees. What do we know this angle is? Well, we have that square on the other side, so on this side there has to be a square. We know this is 90 degrees. So if I add all three of these angles up together, they should equal 180. So 90 plus 35 is 125. So whatever this angle is, it's whatever I have to make up, whatever I have to add to 125 to get 180. So that is 55 degrees. So the interesting thing is that I'm only given one angle, and I can find so many other angles. Okay. So go ahead, however you want to take a picture of the way that you shared this stuff, and I would go ahead and insert it, or you can answer these, but just find a way to kind of show your work. You want to be sure that you're able to look back at these type of things. Okay, so that's the end of this module. And so you'll be able to look back at all of these notes to help you out. If you have any questions, let us know.